Hello, my algebra students. The first lesson today is about determining types of functions. I had some people asking questions about this on the mid-year review, but really this is such a key part of what we've learned this year that I'm recommending that all of you watch the full video. I also would recommend that you get out your comp book and write down what we're going over. So nothing in here is new, but again, we're trying to make connections between all of the things that we've learned this year. So this is really a big summary of the three types of functions that we've been studying. So we started the year with linear functions, then we moved into exponential functions, and most recently we've been working with quadratic functions. And we want to be able to determine what type of function it is from a graph, from an equation, and from a table. So again, I would recommend that you write this down and pause as often as you need to so that you're really thinking about the connections between all of them. So first, probably the easiest is that when we're looking at a graph, we want to be able to tell what type of function it is. I'm thinking that this is probably really straightforward for all of you. Looking at a graph and determining what type it is easy. Some of you still struggle a little bit with actually making a graph. So we'll talk about the different pieces of that as well. But remember that when you're making a graph, you can always make a table. So you can always substitute values into the equation, come up with a table of values, and if you remember the general shape of the function, then you should be able to graph it pretty easily. So obviously a linear equation forms a straight line. An exponential equation has a graph that has an asymptote on one side. So here's my asymptote. Oops. Here's my asymptote right. Oh, I don't like how it did this. Okay, I figured out why it was moving the whole thing. So the asymptote is right in here. It's where it gets closer and closer to a line, the asymptote, without ever crossing it. So in this case, my little sketch of a graph is getting closer and closer to the x-axis, but it never touches it and it never intersects it. On an exponential graph, we also have this exponential increasing here where it's getting big pretty quickly, or conversely, it could be getting small very quickly. And then finally on the quadratic equation, we know that we have a parabola with a vertex and a line of symmetry and two roots. So again, the graphs I think are pretty straightforward to look at them and be able to identify the type of function. Next are the equations. So again, we're so comfortable with linear equations now that we know that there's three different types of linear equations. We've got the slope-intercept form, y equals mx plus b, our first algebraic friend. And then we've got point-slope form, which slope is still the m, but one of x1 and y1 is one of the points on the line. And then we've got standard form ax plus by equals c. I don't know why I lost part of my C there. And then I also wrote here in a different color, we also have arithmetic sequences, which are basically linear functions. And we basically rewrite it with a different symbol. So instead of y, we use a sub n. Instead of b, we use a sub 1, which is our first term. And then we're adding, instead of m, we use d, which is the common difference. And then n minus 1 is the term number minus 1. So this really is basically the same equation as y equals mx plus b, just using different letters. So just wanted to put that in there to remind you that arithmetic sequences are linear. On exponential equations, we have y equals a times b to the x power. Remember that the b is the number that I'm multiplying times over and over and over because it's being raised to this exponent. So the exponent is always the variable. The b is the amount that I'm multiplying it times each time, and the a is the beginning value. We also, I put this on here, I wasn't quite sure how to write it to make it clear, but some of you have a hard time distinguishing between the basic exponential function and then when we have growth or decay. So growth this would be a growth when I have 1 point something. I could also have like 0.9, which would be 1 minus something, and we'll talk a little bit more about growth and decay when we dig into exponential functions on the next video. Also here, I wanted to remind us of the geometric sequence. So a geometric sequence is basically an exponential function. A sub n, a whichever term it is equal to my first term, a sub 1, times the common ratio. The common ratio is what I'm multiplying by each time, times, raised to the n minus 1 power. So just wanted to put that here as well, because that's the geometric sequence, and we'll spend more time on that in our next video. And then finally, this should be really comfortable for you because we've just finished working with it. We've got the two types of quadratic equations, standard form and then vertex form. So vertex form, we know that HK is the vertex. Standard form is, we have to use the x equals minus b over 2a to find the line of symmetry and the vertex. All right, so moving on to the table. We know that in a linear equation, we have a constant rate of change. So as our x value goes up 1 each time, our y value goes up 5. So our slope in this case is going to be 5 over 1. That's our constant rate of change. In an exponential table, instead of adding 5 each time, we're multiplying by a number. So anytime we have x going up just one, up by 1 each time, we're going to be multiplying on the y side. Our output is being multiplied. So that helps us identify an exponential function. And then what we recently learned, but I'm not sure that we were totally solid with it, is when we're looking at a quadratic function. Again, our x is just increasing at a steady rate. The y value is increasing. And some of you would have described that you knew this was a quadratic equation because you can tell that it changes directions, but I actually just put one side of the parabola here so that we can't just rely on the fact that it's going to change directions and have a vertex. But if I look at, it's increasing by 1, 3, and 5 each time, but my second difference is constant. And so that's the key part that I think we weren't fully solid with on our last unit, that this, when I find that second difference, that's going to be constant. So again, that's just a quick review of the different types of functions. This should be really, really solid for you. So if it's not, pay a little bit of attention of studying the pieces that aren't, and shoot me an email if you have any questions.